During this section, you'll hear these words mentioned a lot: monomer, polymer, polymerization. Can you explain what they mean? Pause the tape here and have a go. How did you get on? A monomer is the individual substance which makes up the polymer. A polymer is a long repeating chain of monomers, a chain of smaller molecules. Polymers are also called plastics. Polymerization is a process of turning monomers into polymers. Alkenes are the basis for making plastics, so they are very important.
A mixture of alkanes from the refinery is fed into the furnaces behind me. In there, it is heated to very high temperatures, which cause the molecules to break into smaller molecules known as alkenes. This process is known as cracking.
The carbon atoms in alkanes are linked by single chemical bonds. Cracking produces alkenes, which contain a double bond.
This is ethene. It has two carbon atoms attached by a double bond. Each of the carbon atoms has two hydrogens attached. The double bond allows us to join lots of these molecules together to make polyethene or polythene.
Polythene is produced from ethene by polymerization. Ethene is a gas, and a strong vessel is needed to contain it, since the process takes place at very high temperature and pressure. Even under these conditions, polymerization won't go by itself, so a catalyst has to be added. Large amounts of ethene gas are pumped in along a pipe to create a high pressure. The more ethene molecules there are to collide with each other, the faster the polymerization will happen. Once their double bonds are broken, the ethene molecules can link together using single bonds, and ethene gas becomes solid polythene, one of the most widely used polymers.
Polymers are made of very long chain molecules. I've got a model here of polythene. The black beads represent the carbon atoms and the white beads represent the hydrogen atoms. A typical molecule would have many thousands of these carbon atoms all joined together, and on this scale it would be a few kilometers long. The bonds between the carbon atoms are covalent bonds, which are very strong, but it's possible to rotate the molecule around these covalent bonds, and this makes these long chain molecules very flexible indeed. These beads are a much better model of what a polymer chain is like when it's warm and flexible. And we can mould it into whatever shape we like. To keep it in that shape, we cool it down. And this does two things to the molecules. Firstly, it can stop them rotating around the covalent bonds. And this locks the polymer chain in shape, therefore it can't move. The second thing it can do is, as we cool it down, the polymer chains packed together very closely, and they don't have room to move. Therefore, again, they're locked in shape. If we heat this polymer up again, it will become flexible again. And polymers that can be processed like this are called thermoplastic. There are many different thermoplastics with different properties, but they can all be moulded in this way, and that's what makes them so useful and so widespread.
You should note that the polymer takes its name from the monomer. For example, ethene, the monomer, becomes polyethene, the polymer. Name the polymer formed from propene. Name the monomer used to make polychloroethene. The polymer formed from propene is polypropene, and the monomer which forms polychloroethene is chloroethene. Here's an example showing the process by which the monomer, chloroethene, becomes polychloroethene. Here's the monomer structure. The double bond breaks and new single bonds are formed. These join up to form the polychloroethene polymer. Now try it yourself. Given the structure of this polymer, work out the repeating unit and the monomer. The polymer we showed you was polyphenylethene. And this is its repeating unit, which corresponds to the monomer phenylethene. Test your credit level knowledge. Use structural formulae to show how 3 propene monomer units join to form polypropene. Part of the structure for polychloroethene is shown here. Draw the structure of the repeating unit. Draw the structure of the monomer unit and name it. Here are the formulae showing how 3 propene monomer units join to form polypropene. The double bonds on the propene monomers break. New single bonds are formed and the monomers join up to form polypropene. And here's part of a polychloroethene molecule. The repeating section is shown in brackets. The monomer is chloroethene.
In the world of tomorrow, plastics will certainly call the tune. The ingenious alchemy of coal and oil provides the material. Ingenious machinery presses and stamps and molds the material into a wide variety of products, articles for household use, as well as tools for industry.
The future will bring plastic fabrics wondrously fine, yet resistant to wear, wrinkles, and stains. There will be furniture combining strength with lightness, comfort with eye appeal, with many contributions of the kingdom of plastics designed for practical, gracious living.
The new streamlined plastics present a colorful array. The great range of hues and shades in plastic products presents a challenge for reproduction that is easily met.
So in the years ahead, dreams like this and many more will become realities.
Plastic has a number of advantages. It's strong, lightweight, hard-wearing, heat-resistant, easily shaped, waterproof, and acts as an electrical insulator. It also has advantages over natural materials like wood, which rots, and iron, which rusts. But there are disadvantages too. Most plastics are non-biodegradable. They don't rot away and they can pollute the environment. And many plastics burn or smoulder to give off toxic fumes like carbon monoxide.
One of the great things about plastic is its strength and its durability, but that can also present us with some problems. If we throw plastics away to a landfill site like this, they won't rot and they'll be here for years and years to come. So what can we do with plastic? We could reduce the amount that we use. We could choose things with less packaging. Or we could reuse plastic, like by refilling bottles. We could burn plastics, but that could release harmful gases, and also once we've burnt it, the plastic's lost forever. So one of the best and most practical options for plastic at the moment is to recycle it.
Here at the factory, we recycle everything we can. We recycle our plastic waste and products at the end of their life. Things such as crates, old dustbins, polythene bottles. And this is how it ends up. This we can take and reprocess, reheat and form into anything we want.
The way I remember the order of the alkanes is from the first letters of the rhyme, monsters eat pupils but prefer hairy haggises, okay? That gives you methane, ethane, propane, butane, pentane, hexane, heptane and octane.
I found it really helpful when I was making my class notes to use really brightly coloured biro pens. This meant that when it came down to revising, I found it easier to concentrate on the page for longer.
The questions towards the end of the exam booklet are not necessarily the most difficult questions. Keep working through it. Try to put an answer down for every question. Don't leave blanks. Make sure you attempt the questions at the end of the booklet.
When you're writing revision notes for yourself, try and use word chains so that you can link one word to another quite easily. For example, if you're trying to learn about alkanes, you could write that it had single carbon-to-carbon bonds, the general formula was CnH2n plus 2, and so on like that until you get to the end of the chain so that you have all the information about an alkane and it just comes to you.